All right, hello everybody. Happy Friday to you all. And yeah, wherever you are joining us in the world right now, whether it's the start of your day or whether you're just kind of gearing up for the weekend as I am, really appreciate you being here, spending a little bit of your day with me in this little creative workshop that we're going to have going on. And yes, this is a replay, a kind of retake, as it were, of last week's session. So a big thank you to anyone who's potentially coming along, rejoining this session after joining last week's. It was, you know, I definitely kind of felt like there was going to be some teething issues to try and get past, etc. So hopefully, fingers crossed, things go a little bit smoother for this session. We're doing it once again on both Zoom and also on YouTube. So welcome to everybody who's joining us over on YouTube as well. And I'll be keeping an eye on things on my second monitor there, and hopefully everything's working out okay for you on that side of things too. So to get things rolling, a bit of audience participation to get things rolling today. I have a question to ask you, and here it is. So because we're going to be looking at animation and animated characters today, I would like to ask you, what do you think right now is the very best animated show that's currently on TV? So do you think that Simpsons is still, you know, king of the crop there, or are you a fan of Rick and Morty perhaps? Let me know. Maybe there's some hidden gems that even I'm not aware of. Give me some of your suggestions. I'll keep an eye on both sides of the divide here for any answers coming in. So Steve reckons it's either Family Guy or Simpsons, depending on what kind of mood you're in. I've seen a really interesting Family Guy themed storyline activity that a community member put onto LinkedIn. I think it was either yesterday or the day before. That looked really cool. Well, any iTech. Amy not watching any animated shows? Fair enough. So yeah, I don't know if anyone's come across another show that's on Netflix called is it called Love, Death and Robots, I think? I've actually got a friend who I went to university with at Nottingham Trent, who was actually an animator on that show, so that was really cool to see his name coming up in the credits for that. Couple more coming in here too. Oh, Avatar: The Last Airbender. Yep, I know that one very well. I think is that another one that's on Netflix as well. There's some really great ones out there, especially on streaming platforms. Lots of really great shows right now. Yes, thank you very much, everybody. Some top picks there. I would agree definitely with what Steve was saying there. I think Simpsons definitely seems to continue to just go on and on. It'll be amazing to just see how far into the distance that show really does go forward. Okay, so today's session, as I say, is going to be a repeat of taking a look at GSAP and the way that we can create scripted animation techniques, looping techniques, as well as timeline or trigger-based techniques for animating characters within Articulate Storyline. So we're going to be combining a number of different approaches, as it were, to making this come together, because we're going to be able to take advantage of the new JavaScript API that Articulate have now built into Articulate Storyline for targeting elements on our slide. And we'll also be taking advantage of GSAP, of course, and its rich array of many different creative opportunities for animating and creating tweens for objects on our slides. So in terms of what you're kind of looking at here, my starter project, as it were, if I can perhaps jump to full screen at this moment, and we'll go into things into detail. Okay, so I just want to jump into Photoshop to begin with and just take a look at the kind of composition of this particular character that I'm using here. So this is a character that I downloaded from the Envato marketplace, and you can find these types of characters, illustrated characters in many different places, Shutterstock, for example. Typically what you want to look out for are any composition files that can help you to separate the specific elements, specific parts, body parts of the character that you might be looking to animate. So as much as we can break up our character as much as possible into those individual components will allow us then to do more fine-tuned animation control of those particular elements. So you can see this is the kind of starting point, as it were, the main character. And then what I've done in Photoshop with this one is just take apart and just basically create all of the individual elements of the character. So I've basically got his eyes, the eyebrows, the mouth shape, the head is its own object, as it were, left ear, right ear, and then the main body, and then the tail. So in effect, I've just got all of these individual elements broken up, making up the composition of my character. And then coming over and jumping into Storyline, now it's basically a case of layering and piecing together our character on the timeline in order to basically recreate the composition of the character. So as you can see here on my slide, I basically got just one slide composition. This is essentially like a starting point for perhaps an e-learning course for young people. And then here is our character, who's going to be the kind of mascot, the main character energy going on, as it were, for our activity. And this is just a PNG file, or this is just the main composition file. As you can see, so that's just effectively the full Fox character in one file. So if I go ahead and hide that element and then just start to show all of these individual PNG files that I've effectively exported out from Photoshop one by one, they're just in a project folder, and then I've gone ahead and brought them into Storyline in order to build up the character and piece him together onto the slide. So what I can now do, what I can start to do, is use Storyline's grouping system in order to group together some of those elements that I might want to animate together, or effectively have move and tween in a, let's say, in a kind of similar essentially together, as it were. So for example, with the head shape, it'd be great to effectively bring together the eyes, the mouth, the eyebrows, etc., so that I can animate that group in order to move the entire head, rather than having to individually animate each point in order to do, for example, a head turn or a head tilt or something like that. So what I'm going to do here is pick out what needs to go into that head composition. So if I go for the ears, obviously the head PNG file, the mouth, 2 eyes, and the eyebrows. So that in effect brings everything. It's going to be really interesting, I think, with regards to all these new nodes that are now visible on the slide, with regards to the bounding box, the rounded kind of rectangle corner shapes that you can now kind of tweak, as it were, directly on slide. When it comes to smaller objects, it's going to get quite cluttered, I think, as you can see there. So it's it's going to be kind of an interesting developer experience at times, I think, with that one. So I'm going to right click and I'm going to bring all of these elements together into a new group, and let's just call this the head group. And now what's really nice about groups and about shapes, everything that we would want to animate in Articulate Storyline, if you take a look, when we right click on this group, you can see that Storyline creates its own unique identifier, its own unique data model ID that we can use to target that element through our scripting in JavaScript. So being able to target both the group as a collection of objects, but also individually targeting specific elements like the eyes, the eyebrows, etc., all individually, all on their own. So I could now, if I want to, go ahead and bring together perhaps the other elements as well. It's not necessarily majorly important to do so, but if I was maybe going to move the entire character around the screen for whatever reason, it would just make things a little bit easier to have effectively our main Fox group a group object in order to then pick up and drag that object if we wish to do so. Okay, so the first thing I'd like to do to start bringing our fox character to life here in Articulate Storyline is animate the fox's tail. So effectively what I want to have there is kind of a rotation effect going on with the tail, going clockwise, going counterclockwise, but it'd be really nice if we could actually do something that's quite random, as it were, in terms of how much of a strength the counterclockwise direction may go and the duration of time that might take versus then going clockwise. Maybe that would be faster, maybe it would go less distance, maybe more distance, just because if we're able to basically, you know, tweak those velocities and have them different every time the animation runs, then we get it's just something that's a bit more lifelike, as it were. Otherwise, it's just going to look like a pendulum, you know, just kind of like going backwards and forwards at a continuous strength. So that's what we're going to do. So I'm going to show you effectively a technique that we can apply and also using GSAP in order to make that animation happen, and also how we can create a looping effect in order to get our animation tween to play over and over continuously, going clockwise, counterclockwise. So on my slide here within my triggers panel, I'm going to create an execute JavaScript trigger when the we'll go for when the timeline starts. Oh, let's actually do it this way. So what we'll do is we'll have the Fox group, the group object here on the slide. We'll have that animate in with a fly-in effect from the right. So when the layer shows, he just kind of flies across onto the slide. And then we'll use the completion state of that animation for when we want our movement of his tail to begin. So we'll say execute JavaScript trigger when, and tell you what I'll do here actually, if this actually works, this will be really great. One of the bits of feedback that I had from the last session was just about the zooming, or just being able to see what I'm doing on my screen here as I'm working on the code. Obviously, the JavaScript editor in Storyline leaves a lot to be desired, really, in terms of its usefulness, especially when doing sessions like this. Its text is so small. So what I'm going to try and do here is use a live zoom effect in the software that I'm using, and hopefully on your side of things, I'm just checking on zoom there. It might take a second for YouTube to catch up, but it certainly looks like this would be preferential to be able to see me working like this, as opposed to me kind of taking snapshots and zooming in and out. So I'll go ahead and do that. Just to answer a quick question there from Stacy, can you use SVG files instead of PNG to stop any pixelation? Yeah, absolutely. Of course you can. So of course SVG is supported is supported in Storyline natively. So if you're working with an EPS file, for example, and maybe rendering your elements out of Illustrator as opposed to Photoshop, then rendering with rendering out to EPS, for example, or to SVG would be a great way to do that. Steve's just picking up on the point about GSAP libraries being free, and yeah, that's another great thing, another great reason to get into this level of development and start kind of seeing what GSAP is really capable of in Storyline. You know, hopefully this kind of gives some creative ideas for you to go out there and to kind of explore and play about with these animations in your own time, as it were. So let's get back to what we were just doing then. So let's create a trigger, execute JavaScript when the animation completes of the Fox group entrance. So you can see that we have this effectively, this would be where we would have our list of motion paths, etc. And I think emphasis animations also are included in animation complete triggers as well. But we can also target start and end of transitions on slides as well. So that's really cool. So we'll go ahead and use that. And then here is our JavaScript editor, which is where we shall go ahead. And first of all, what we want to do is target the correct object. So we can do that. As you can see, Storyline provides us with this object reference dropdown. So this effectively is using the new capabilities of the JavaScript API, and the JavaScript API in itself provides a number of property modifiers, as it were, that can target the specific object that is created as a result of adding an object reference to our JavaScript editor window in Articulate Storyline. So if I go ahead and target that tail object, hopefully as you can see down the right hand side, it's that kind of bounding box around that entire tail PNG image that's on the layer there, and I'll go ahead and add that to our JavaScript editor window. And as you can see, we are targeting, or rather what we're creating is a constant. So this in effect is our reference to that tail object for our script, as it were, for creating our script. But I don't want to use Storyline's method of targeting the object, as it were, because that limits the number of properties that we'll be able to apply and customize that particular element within our document. So instead, I'm going to use a method within the document itself called a query selector in order to identify the div tag, effectively the container of that PNG file, when our project is rendered and published out of Storyline, in order to have that be the element that we are targeting with our JavaScript instead. So rather than saying object, I'm going to remove that word there, and I'm going to replace it with document.querySelector with a capital S. And now we need to define what the specific attribute, property, what is it? Yeah, so it's a specific attribute that we want to target, find within our document that relates, or rather tells our code that that is the tag that we want to apply our animation properties to. So we are going to be targeting the object, or rather what I need to do here is include this in square brackets. So open and close single quotes, open and close square brackets, and then within the square brackets, I type my attribute name, which in this case is going to be data-model-id. And then in double quotes, I include the name, or the title, as it were, of that particular attribute. So in effect, Storyline has given us, handily given to us, what that data model ID is going to be for our tail object. And we'll be able to see that this is definitely the right object, or that we are targeting and we're getting the specific document tag that we are hoping to get from our first line of code there in JavaScript by simply console logging the result, or rather what is contained within that tail constant. So I'm simply just going to print the result, as it were, or what effectively has now been created as the reference assigned to this new tail constant. So let's go ahead and, oh, I might have accidentally, oh, I don't believe it. Beg your pardon. I'll try and do this as quickly as I possibly can. I've just realized that I don't hit escape in order to come out of the zoom mode. That's what I've just learned here. Let me try and get this typed as quickly as I possibly can here. So data-model-id equals, and then in double quotes. Okay, so let's preview the slide now. And then Articulate Storyline handily provides us with an inspector window. We no longer have the situation where we have to render our project, or rather publish it to our desktop in order to see our JavaScript in action. So now you can see when our script has ran, it has returned the specific div divider element tag within our document, and effectively right there is the data model ID that has been set for this object. So this in effect is the tag within our document that contains that tail shape. And if you wanted to actually dive into that further, you could actually perform a search. If I'm able to SLRJ, let's see if I can just do a quick Control F to find that. SLRJ. Yeah, so there it is right there. So if I actually bring this developer tools over here, and then if I highlight my mouse over that div tag there, you can now see the Storyline is showing us effectively what is that element that I now am highlighting over in my code view on the slide. So that's clearly showing that that is definitely the tail PNG elements that I'm effectively wanting to now go ahead and animate. Okie dokie, so let's comment out that console log line. And now let's go ahead and set up our GSAP animation tween. So the method that we can set up here in our code in order to create a GSAP based animation, a script based animation for that tail object, is to use the GSAP.to method. So the GSAP.to method effectively allows us to take an object that sits on the slide in its current state and its current position and its current kind of properties in terms of rotation, scale, etc. And then we can define what we want to change those properties to. So we kick things off. I'll go ahead and zoom in once again. Sorry, just want to get this as best I can here for the benefit of the stream. So we'll kick things off here by writing gsap.to. And then we open and close parentheses, and then we might as well add our semicolon at the end there, which denotes the end of that code block. And then within the arguments here for the gsap.to method, we first need to declare what is the element that we are animating based on its reference name, i.e. it being a variable or a constant within our script. So we'll declare that we are going to be animating the tail object, which we have declared on line 1. And then we add a comma. And then we add open and close curly brackets. And all I'm doing here is just moving the closing curly bracket and closing parenthesis there onto a separate line. We can, in effect, if we want to, write our gsap.to animation method across an entire line, and it could, go on as far as it needs to go ultimately. But this is just a better way of us being able to kind of see what we're doing and for it to be more legible and readable, as it were. So what we want to do, or what the specific property that we want to animate, is going to be the rotation value of the element. So we'll type rotation, and then I'll start with just a kind of static number to begin with. So I'll say 90. So a number that is greater than 0 is going to move that element in degrees clockwise. And if I use a negative number, it would rotate that object counterclockwise. So this, in effect, is going to rotate that object 90 degrees on its center axis. And we'll see that in a second, and we'll talk about why that's important, or how we'll modify that in just a second as well. Now, this is a gsap.to method, so we also need to declare how long the animation effectively is going to play for. So I'm going to include a duration property, and we'll say duration of 3 seconds to begin with. So again, this is based on seconds. You can use decimal in order to get fine-tuned results, 3.15, obviously 3.15 seconds. And we can also declare an easing strength. Now, GSAP provides a number of predetermined or rather named defaults, as it were, for easing, and there's loads. There's loads that you can actually find. If you Google GSAP easing and go to the GSAP documentation website, you'll find that there's loads that you can effectively work with there, and it actually provides a really nice graph editor that shows you the strength, as it were, to help you visualize what the easing property is going to look like when you apply that to your own object in Articulate Storyline. So I'm just going to use one of the defaults from GSAP that I know is available, and we can declare, much like how in Storyline with our animation paths, we can have a transition, or rather we can have an ease in and an ease out, or we can have both. In effect, what we're doing here is we're just declaring almost kind of a constant strength, as it were, for that motion, but then we're going to have an ease in and out on both ends of that motion taking place on the during this tween. And we'll leave things there for now, but we'll obviously come back and work on this a little bit more in just a second. But I just want to... Oh, no, I've hit escape again, haven't I? Oh, God. When am I going to learn? Good grief. I need to get, like, I don't know, just something printed, like, right above my monitor or something. Control 4, not escape. Okay, quick as you can once again, Chris. Come on. gsap.to, and then tail, and then open close curly brackets, and then we said we were going to animate rotation as 90. We were going to apply duration as 3 seconds, and we were going to apply an ease property of sine dot in out for both. Yeah, that's where we got to. Okay, cool. So let's preview. And then what we should now see when our animation runs, and the animation is going to run when the transition finishes. So there, can you see now that the tail is starting to rotate, and now it's finished? So it has rotated 90 degrees and it's gone at a constant strength, but it has basically done a bit of an ease in and out as it went through its animation cycle there of 3 seconds. But of course, as you can see, what's happened there is that the rotation is happening almost like, you know, imagining that we've got basically a pin right in the very middle, the top center middle of that object, and that's where the rotation is in effect taking place. So we can apply what's called a transform origin property to the object in GSAP in order to change that value and declare effectively where that rotation pin needs to be instead. So I'm going to go back to the JavaScript, and then directly below this ease property, I'm going to create a transform origin property, and we need to declare this in single quotes, or you can use double quotes actually, whatever you prefer. And then we declare 2 percentage values for the X and Y. So in effect right now we're at 50%, 50%, but I just want to click OK on this and then just take a look at what we're dealing with here. So just imagine, you know, basically what we want to try and do is get our rotation happening as close to where the tail effectively connects with the body of the fox character, round about there. So you can imagine that on this X axis here, we're only at about, say, 10%, in the region of 10%, in that sort of vein. And then down here, we're somewhere between sort of 80 and 90, let's say. So we'll, you know, this will be sort of trial and error. We can try 1080, 1090, and then whichever one we're most happiest with, we'll stick to. So let's go back to the JavaScript, and then within the transform origin here, I'll go ahead and type 10% space. Let's try 80 to begin with. Okay, so 10% and 80%. And then click OK, and then let's preview once again. Okay, so fox character comes in, and there we go. That's much better. Clearly 90 degrees is taking it a bit too far in terms of the animation, but if we keep things subtle and effectively have the animation going no more than, say, 15 to 20 degrees in either direction, then we know that we've effectively got the result there that we're looking for in terms of that animation, that movement of the of that tail moving on the slide there. So that there, as you can see, is quite perfect, and in effect what I was hoping to achieve. Okay then. So now we are in a position with our code here to start thinking about how we are going to create that looping effect, as it were, and how we're going to effectively have our GSAP.to method repeat itself. Basically wait until it's completed its first run through, and then update its properties to something new, something random as it were, and then go ahead and play again. So effectively just a continuous non-stop movement of the tail on the slide whilst the user is effectively on this slide in Storyline. So what we'll do is we will create a couple of new variables up top here to effectively hold our values, as it were. Well, as a matter of fact, what we'll do is we'll include all of this within a function. So what we'll be doing is we'll be wrapping the GSAP.to method within a function contained within our JavaScript. Effectively, this is like a function, this JavaScript that we're creating here, and then we'll declare, or rather we'll have that function be named and called again and again by itself in order to create the loop. So we can easily we can easily create a function in JavaScript here by typing the name function, and then we give our function a name. So I will call this wagtail, for example, and then we can declare any arguments, any values that we want to perhaps bring into that function if the purpose of our function is to take something in, do something with that value, and then spit it out again. In this case, the function is not designed to do that. It's effectively designed to make things happen, make some animations play on our slide. So we don't need to pass in any arguments on this occasion. And then we just include what's in our function within open and close curly brackets. Okay, so what we can then do just right at the very end of our script then is declare the function in order to make sure that it actually runs for the first time. So in effect, when we create a function, that's effectively like a block of code waiting to be executed, waiting to be told, right, it's my time to shine. But basically, go ahead, wagtail, do your thing. So we need to basically declare or set up within our code when the function needs to happen. So in this case, we just want it to run when the JavaScript runs. So we just go ahead and pop that at the bottom of our JavaScript editor window here in order to get things rolling. So within the function, what we'll do is we shall create a new variable. We can declare variables in one of two ways in JavaScript. You can use var for variable, quite easy to remember, or you can use let. In the context of coding in Articulate Storyline, there's no real great difference between the two. So whatever you would prefer, because ultimately what we're doing is all confined within the context of this block, as it were, this code block. So var and let are very much interchangeable in this in this kind of tutorial, as it were. So let's create a variable for to contain our angle value. So that's going to be what the rotation value is going to change to, rather than what it is currently, that value of 20. And then what I'm going to do is I'm going to create a variable which will declare outside of the function to begin with, to control what is the direction, or rather the anti-clockwise or clockwise property of our rotation, and that's what we want to be able to change each time the function runs. So we'll name this variable current direction. And then what we're going to do is set that to a number value. So I'm going to set it to -1. So the idea is that what we'll be able to do with that number is times it by -1 each time, in order to change it to -1, back to +1, back to -1, back to +1. And then we'll be able to use that as a multiplier for our rotation value in order to change that to go from clockwise to counterclockwise. So you'll see all of this kind of come to life in just a second, hopefully, if all goes well. But just to annotate this, just to say that a -1 here would be moving the value to the right, because we'll be timesing our number by -1, turning it back into a positive integer. Whereas if it was a +1, then we would be moving that object counterclockwise instead. So effectively going left. So as a matter of fact, maybe that's not as intuitive as actually saying clockwise. Oh, clockwise, and +1 is counter clockwise. Okay, so what we'll now do is underneath or within our function, so where I've got my angle set, and currently it's just an empty variable waiting to be filled and put together, as it were, what we'll now do is set up a method here. We're going to set up a conditional statement in order to make that value change, as it were, as well as set a random property for our rotation value. So what we'll do is we'll say, or we'll declare a condition here, an if statement, and this is what an if statement looks like. Just to, if I can zoom in on this. Here we go. So we always start with what are the arguments, what are effectively the things that need to return as true in order to then run the code block that sits within the open and close curly brackets of our if statement. So in this case, what we're going to do is we're going to say if the current direction value, which is set up here, let me just zoom in once again for you, sorry. There you go. So if the current direction value is equal to the value of 1. So I'm using, you can use 2 equals or you can use 3 equals. Effectively equals is 3 equals is like a strict value denoter there. So we're effectively saying that if the current direction variable is equal to +1, and now we're going to declare what is going to happen when that returns as being true. And what we want to do is update that angle property that we've just created up here in order to set that to be a positive integer, as it were, a positive a number. So what we can do in order to generate that random number, by the way, there is an inbuilt random generator, like inbuilt property method that's available in JavaScript. But just because this is intended to be quite a GSAP focused tutorial, what we will do instead is, if I'm perhaps able to just load up a new window here, I'm just going to jump into GSAP, or rather jump into GSAP's documentation. Okay, let me just bring this onto the screen here. Just double check that you're able to see this on your side. Yeah, okay. So effectively, the GSAP as a kind of programming language, a framework, an animation framework in itself, provides a number of what are called utility methods that can be used to help effectively do things in GSAP. And there's a number of various things that effectively can be done to help produce and generate properties, and you know how those effectively can be created and generated in code using GSAP. But as you can see, one of those utilities right here is the ability to create a random number. So in effect, GSAP provides us with that method to be able to allows us to create a number between two values that we can declare within the arguments opening and closing parentheses of that property. So back in our code, we'll go ahead and use that. We'll put that to use for what we are doing here to declare our random angle. Beg your pardon. Okay, so we can declare, we can write GSAP dot utils dot random. And then the idea with that is, as we saw on the page we were just on, we just need to open and close parentheses and then declare the two numbers to define the start and end points for the limit, as it were, for the random number that's going to be generated. So I don't want to necessarily take my animation too far. As we just saw, the maximum that I maybe want to go to is 20, and maybe even that was perhaps a little bit too far. So let's try just creating a number somewhere between 10 and 16 degrees when we are going in a clockwise direction. Okay, so that declares the angle value if the current direction is being set, or rather is declared as moving us in a clockwise direction. Now we'll say else. So basically meaning that if what is our argument here is not +1, so i.e. it's going to be, if it's -1 this time, instead what we'll do is we'll set our angle, once again using the GSAP utils random method here, so I'll just copy and paste this down here, and instead we shall declare a negative range. So we'll go for somewhere between -9 and -1. So it doesn't go as far counterclockwise, and perhaps goes a little bit more when it's moving clockwise. Okay, so now what we need to do is put that new angle value that we've just created here, rather than our rotation value here being hard-coded, so right now it's 20 and that's just the way it is, we can go ahead and instead use our variable name and pop that in as being the value for that rotation property in our animation. So that's always going to change every time the animation is run. Okay. We'll come back to perhaps animating the duration in just a second. let's leave the duration as 3. But what I want to do is just leave that code as it is right now in order to hopefully preview and see the result just when the animation runs for its first playthrough. And what we should see each time the animation runs is that we're going to see it move ever so slightly there, actually, from its starting point. It might have just been a few degrees. And then if we animate it again, we might see it move a little bit more next time. Yeah, so it's moved a little bit more in strength that time because the rotation value is going to be different every time the function is run. Okay, so looking good. We're in good shape right now. So next up, what we want to do is have that rotation value, or rather what we want to do is effectively have our GSAP.to method, or rather our wagtail function, now repeat itself. So again, another really handy method that property that GSAP provides to us that we can use to implement this is the ability to create what are called callback functions. So in effect, what GSAP allows us to do is declare a block of code that we can write ourselves, effectively a custom script that is intended to run at a specific time during our animation. And what GSAP provides to us are 3 different options that we can select from. So we can go for on start, which effectively would run that code immediately when the GSAP.to method begins. We can have on update, which would run that code every single time a new frame of the animation runs. So in effect, that can be used to do things like collision checking and perhaps property changes that play throughout the animation, because that allows you to run code that effectively runs itself every time the frame changes in the animation. And then lastly, the one that we're going to be taking advantage of here is going to be the onComplete method. So the onComplete, as you might imagine, as soon as the very last frame of the animation has finished, that's when the onComplete function, callback function, would then be declared and called. So what we can effectively do is just say, well, we've got a function. We know we've already declared our function that we want to run when the animation is done. So we'll just say that that's what we want to happen. So we're basically saying onComplete, go ahead and call the function of wagtail again. So that will go ahead and kick things off once again. And as you can see, the function starts by declaring angle as not effectively in beginning right now. Current direction may be +1, may be -1, depending on what it has been changed to in the first time that the function was actually ran. And then we go ahead and update what's happening in the code. As a matter of fact, I just realized what we do need to do is actually update the current direction each time the code does run. So what we actually do need to do here is to update current direction by timesing it by -1. So in effect, take current direction and then multiply itself by -1. So that's going to run every time the function runs, and then that will change it. So as a matter of fact, by doing that now before this if statement is ran, means that the first time that the code actually runs, it will now move clockwise rather than counterclockwise when we previewed our project. So we'll see that all kind of changing the next time we run the code. So including that with what we have now just done, and we've just said that onComplete, we are going to redeclare the function, so that in effect will run everything once again within the script. So the only thing that we now need to do, which is optional, but I would like it so that the duration value, which as you can see is currently set to a static a value of 3 seconds, perhaps that is something that we update randomly as well. So rather than we don't need to do anything in relation to going backwards and forwards, negative plus numbers with this one. So we'll keep it nice and simple in our code here, and we'll just say that, or rather we'll declare a variable value for holding the duration number. So we can call that duration num, for example, or duration seconds perhaps, equals, and then we'll use the GSAP utility once again to create a random number for this between Somewhere between, say, 0.5 and 1.5 seconds, or maybe even less. So let's maybe go for somewhere like 0.75 seconds to 1.5 seconds. So that's going to declare a number somewhere between those two values, and that's how long this particular animation is going to play for. So the only thing we now need to do is take this new variable that we've just declared, copy and paste that in place of that number that we have just created. And then, all being well, just checking everything through once again, so we can see that this is our function that runs from here to here. We call the function for the first time in our script itself down here. We declare what current direction is before we get into the function, but the function itself is going to update that current direction to -1 and +1 every time this function is ran. And then we do a check to see whether it is a plus or negative number. If it is a plus number, we're changing the angle value to be somewhere between 10 and 16 in rotation degrees. And if it's not, or rather it's a negative number, we're going to declare a negative number somewhere between -9 and -1. And we're also at the same time creating a random number for the duration length in seconds for this particular run of the animation itself, of the animation tween. And then the GSAP.to method goes ahead and does the animation work itself and gets everything moving. So everything looks to me like it's all come together. We'll be able to obviously jump into the console area in Storyline. If there's any issues, we'll be able to check that out and maybe see if maybe I've named a variable wrong, or another part of the code has perhaps been named wrong. But let's go ahead and give it a go and see what happens. So now hopefully we have the start of our Fox character coming to life. Oh, we do have an issue. Let's take a look what's going wrong. Cannot read properties of undefined random. Okay, so I've used the word random in the wrong way. So that's clearly when I'm declaring a random number using the GSAP utilities. So let's see where I've gone wrong particularly. Oh, I see where I've gone wrong. Right here. Maybe in the chat people are shouting at me, you know, I would be doing the same thing. Like, Chris, you've missed an L. Oh, sorry, no, you haven't missed an L, you've missed an S. You've written util rather than util. So that's clearly, as you can see, this is the life of, you know, programming. This is what it's all about. Taking the cues, as it were, from that console log, seeing what it's telling us, and then it's like, right, okay, that's definitely what I want to be looking for. I'm using the GSAP random method. So where have I gone wrong when I'm trying to implement that particular block of code? So let's go ahead, now that I've made that update, preview and see what's going on. Okay, and there we go. We have that nice rocking motion, and as you can see, it's sometimes just going nice and lightly, sometimes it's a bit more animated. There we go, so it's just starting to sway a little bit more. But it's just, as I say, it's not necessarily just that pendulum effect that would just make the character look quite monotonous, if that makes sense. Just something that, in this sense, you know, we're using those random generation values in order to add more life and to bring more character, give more character to our Fox character here. So of course this workshop is show and tell, very much about just kind of showing the techniques, hoping to give you, you know, starting points and ideas for going forward. Much like in our first session, actually, I knew going into that one that I was going to be biting off more than I can chew, really, in terms of everything that I want to animate with a character. So we may very well do this workshop as a part 2 and as a part 3. But I think we have enough time to maybe jump in and do some more animation. Maybe we'll do something with the head next. But let me just check in on everybody, see if there is any kind of burning questions that have just come in, and any issues or any questions that you might have at this particular moment in time. I really appreciate the community feel as well that we've got going on, people answering questions whilst I'm working away here, obviously trying to keep things fluid and keep things moving. It's wonderful that there's clearly some people here that have some pre-existing GSAP knowledge that we can take advantage of here as part of a part of a nice community group that we've got going on. I love that Stacey jumped in with the answer clearly before I went wrong as well. Clearly saw what was going to happen there before it even happened. So I love that. I think we have had an answer already there about the get player. That changed fairly recently, not quite a few months ago, but before the JavaScript API came about, effectively the get player method is now declared in a separate file that gets published by Storyline within your document, within your files, as it were. So the user.js file no longer requires you to declare the get player method within all of your functions. So we can just jump straight in with get var small g capital V or set var small s capital V to get the same output, same outcome, which is just a time saver really, which is great. Why didn't I do that? Well, just to kind of show another way of doing it, Steve, really, you know, so you've got multiple ways of potentially doing this type of thing. Yo-yo is another property that exists with the GSAP. Now, what I would say about that actually is that with the yo-yo, you would probably declare the GSAP.to method once and then effectively allow it to repeat itself. So what we're doing is we are calling it ourselves with different properties each time. So whether or not you would have to, using the yo-yo effect, update following, I guess on complete, you could then go back and update, and then whether or not the next yo-yo approach would do the same thing. As I say, it's kind of 6 and 2 freeze. Hopefully you're following my train of thought as I'm describing that there, if that makes sense. And then don't we have to store the source of the GSAP library into Storyline? No, actually we don't. That's a really good question. And the great news is that GSAP is in effect baked into every project that you publish out of Articulate Storyline, at least as things currently stand. And the fact that GSAP is now freely licensed, is it Webflow who currently own GSAP? So in effect they did a really great thing a few weeks ago and made the library itself, the core library, as well as the plugins available to work with licensed free. So GSAP in effect gives us access to, Storyline gives us access straight away to the GSAP core library, and then if you want to, you can download and put into your published projects any of the plugins that you might want to use. There's some really interesting ones that GSAP provide, actually, things that play with velocity for doing quite interesting kind of movement and power and gravity effects, etc. And there's some different scroll based triggers, and they could be applied actually to scrolling panels, and maybe that's something we come to in a future workshop, which would be a really interesting one. Bob, you mentioned using onUpdate to help with collision detection, which I'm having issues with using timeline.to. Any documentation out there to help with that? No, that's a really good point, actually. The main thing to note about using GSAP animation methods in Storyline is that if you are reliant upon using Storyline's inbuilt collision detection trigger, i.e. do something when object intersects. So if you're used to using this and you're basically getting an object, animating that with GSAP, then unfortunately, just the way that GSAP properties work in relation to Storyline properties, Storyline will not detect the overlap, the collision event, as it were. So what we can do instead is run that, or rather run a check for that collision taking place in GSAP by using the onUpdate method that I mentioned. So in effect, what you would have is a separate function within your execute JavaScript trigger that's designed to perform a check between those two objects in order to determine whether those two objects' properties, their X and Y parameters, as it were, have overlapped, have connected, and then that can trigger something, for example, a set var method, in order to then do what you want to do in Articulate Storyline. So it is possible. Sorry if that's not very well described. It probably a bit too much to run into here, but it's probably going to be a good one to cover as a future workshop topic. But just to kind of put that out there, 100% possible using GSAP to do that kind of thing in Articulate Storyline. So how about, like I say, because we've got a few more minutes to play with here, let's go ahead and do something with the head group as our next point of call. So let's say execute JavaScript when the animation completes of Fox group entrance and then we'll add the head group. Just zoom in once again here. Document dot query selector. Probably zoomed in a little bit too much there. So this time our code here is going to be targeting data-model-id equals, and then that's our head group right there. Okay. So once again, in terms of what we want to do with the head group, we might have that animate in, maybe just kind of like tilt, as it were. That's what I had in kind of my demo, as it were. So we'll see if we can quickly create that. So what we'll say is GSAP .to, using the head group as our animation object, and then we want to rotate the head somewhere like -20 degrees, let's say, over the duration of, say, 0.5 or 0.6 seconds. And then importantly, just like we did with our tail object there, the head obviously doesn't want to rotate centrally where the nose is. We want it to be towards the, like at the bottom of the head, as it were, where it connects to the neck. So we want to set a transform origin value. Let's just move this out of the way just to kind of show what we've got going on here. Let's, without losing my work, hopefully I can get the head group highlighted. There we go. So just to show what's going on there. So clearly we just want to go right at the very bottom there, somewhere in this area for the rotation of the head shape itself. So which one was it? This one. So let's set this value to be, again, central. Maybe it was slightly off to the edge there, but let's go for 50%, just see what that looks like. And then right at the very bottom, somewhere like 95%. And then in terms of easing, let's maybe try a different property this time. Ease of, let's go for power 2. So in GSAP, there's power 1, power 2, power 3, and power 4. Each of them just have a kind of faster conclusion, as it were, to getting to maximum velocity with the animation. So we'll just go for power 2.out with this one. So an out easing effectively means that it's running at maximum velocity when the animation begins, but then eases out obviously towards the end of that animation. And let's perhaps leave that, or should I? Yeah, we'll leave that there, because as I say, I'm realizing we are coming quite rapidly to the end of our session here, and yeah, absolutely, we'll be coming back and we'll pick this up. Thankfully, I think this one has gone much better. I can see YouTube is playing much smoother today, and hopefully you guys have had a great experience on Zoom, who have joined us there as well. Just different settings. I'm not sharing my camera this time. I'm sharing the camera as a screen, which just seems to do a much better job. I quite like the result of that one, actually. It was quite a cheeky little head turn, but we might need to play with those numbers a little bit more to get maybe a bit more of a subtle finish, as it were, to the rotation of the head. Let's maybe see what we can do here. Let's try maybe 52 instead. I think the Y property is probably okay, and then maybe not as much. Let's maybe just have 1.2 as the value instead. Let's give that a go. Okay, I think we've got something going on there. So We have a lot to cover still. A lot of things that I'd really love to walk you through with GSAP. I think today has been really great in terms of giving you that first look, that first impression of the GSAP.2 method. Obviously, we looked at using the JavaScript API in Articulate Storyline. We basically combine those two things together in order to achieve what we effectively achieve the connectivity going on in our app between the Storyline object and also our GSAP method, made much cleaner, made much better by the new JavaScript API, which is obviously a great thing. So we will be picking up, maybe in the next session, we'll take a look at adding event listeners to the GSAP method itself so that we can actually have these animations play either when the user clicks, or they might click or tap on the fox, or maybe do a mouse over event instead, maybe take a look at pointer events and using what specific web API pointer events we have in order to make those animations play as well. And what would be great actually with the head tilt is see that play forward as we just saw there, but then how we could then play the whole thing in reverse when perhaps we have that mouse out or the mouse up event. So effectively we have a mouse click, he moves one direction, we have the mouse up, and then he moves in another. And that's achievable in GSAP using a reverse method, and we'll apply that, or we'll take a look at how we can do that using event listeners as well. So just to wrap things up, I noticed we've just got a couple more questions I think that have come in. Did you share a downloadable version of the file? I didn't share this specifically, so this is kind of a show and tell, as it were, Stacey, for this particular workshop. So yeah, it's just really just to follow along and kind of see what I'm doing here, but feel free, as I say, to find your own characters, as it were. It's just because I've downloaded this from Envato, there's obviously just a licensing thing with regards to that as well. For people on YouTube as well, sorry, I feel I've neglected one or two questions have come in there as well. Yeah, wonderful to see as well, so scrolling panels, etc. Yeah, absolutely. Well, that's been a really fantastic session. I'm so glad that this has actually gone far smoother, and this definitely seems to be the way to go in terms of the settings and everything for doing all of this. So I really appreciate you being here, spending your hour with me. I hope you have a wonderful weekend. You will see me actually, just to mention, if I can just quickly bring up the website here. Because we might not be doing this session again in 2 weeks' time, but I'm going to be doing a session actually with Articulate. They basically are starting a new webinar series, like with guests who are joining David Anderson and discussing topics, etc. So I'm going to be doing a session. When is the date of that? Sorry, I might see if I can actually find the... There we go. So it's on Wednesday, June the 11th at 8 a.m. PDT. Is that Pacific daytime? And that's available. You can go ahead and register for that now on the eLearning or the Articulate eLearning Heroes community site. And yeah, it'd be great to see you there. I'm basically going to do a full sweeping view of kind of next level interactivity in Articulate Storyline, all the things like basically what's happening in the world of generative AI, what that means in terms of interactivity, accessibility, and many other ways in which users can engage with Storyline content, Storyline built content in kind of novel, new and creative ways as well. So it's going to be a really packed, really hopefully quite energetic and full of demos. So it'll be wonderful to see you all there as well. So go ahead and find that on the eLearning Heroes website. And yeah, that's it from me. Thank you so much, everybody. Have a wonderful weekend, as I say, and I look forward to seeing you next time. Take care. Bye for now.